Hello and welcome to Chapter 9, Section 4. Today we are transforming quadratic functions. So we understand quadratic functions and what they look like when they're graphed. The primary quadratic function, the basic, very basic one, is f of x equals x squared. You have to have that x squared. Now it goes on to say x squared plus ax squared plus bx plus c, and you can have all of this and you have all of this, but you have to have this. This b can equal 0 and c can equal 0, and that's fine. But a cannot equal 0 or it's not quadratic. So the very, very basis is this, and this is what we're going to be working with most today. Everything else that we see, every other quadratic function, is a transformation of this. So the parent function is f of x equals x squared, and for this the axis of symmetry when we graph it is 0, and the vertex is 0, 0, and it only has one 0, which is 0, 0. It only crosses the x-axis once, so it crosses at this point. Everything else that we do to this equation changes the way this looks, and we're going to find some of the basic ways that it changes so we understand how it's built so we can manipulate it easier. So here in the black we have a coordinate plane and we have f of x equals x squared, and that's the black one, and that's where when x is 1, when x is 1, y is 1, and when x is 2, y is 4. And if we make a smaller than 1, say 1/2, then we get this green parabola. When x is 1, y is only 1/2. So when x is 2, y is 2. So you end up with a fatter parabola. And then we make a larger, 3x minus 2. If you have a bigger a, you end up with a skinnier parabola. If x is 1, y is 3. And when x is 2, y is 12. So it goes up very steeply, very quick. It is still a parabola. It's still curvy in the bottom here. Even though it's so skinny that it might look like a V, please remember that it's not. So if a is negative, either -1 or -1/2 or -3x, doesn't matter what the number is, the rule stays the same, it just opens down. So the takeaway you need to have with this is that the width of the parabola is determined by a. So you can just look at an equation and you can see that if it's going to be a skinny parabola or a fat parabola, or if it's going to just be 1 or -1, so it's a standard size parabola. So let's look at examples number 1 on page 634. When we look at example number 1 in the book, they're doing theirs based on a graphing calculator, and we don't care about graphing calculators. We want to understand the basics of a parabola. So we're just going to look at checkpoint numbers 1 on page 634. And what they want to do is they want us to order them from narrowest to widest. And when you look at -1 here and 2/3 here, you know that -1 is going to be narrower than 2/3. So you can put them in order. Here's the same story. We have an absolute value of 4 here, 6 here, and 0.2 here. So you know that the smaller the number, the wider it's going to be, and the larger the number, the smaller it's going to be. So this is going to really be 1, 2, and 3. So again, we're going to start with f of x equals x squared, and we're going to have that in our basic spot. And we're going to compare what happens if we change c. Here c is a -4. Now because x squared is the same x squared as this, the parabola is going to be the same shape. It's going to be the same width. However, it's going to start in a different place. This one starts at y equals -4. And if you make c a positive number, same story, but it's going to start at y equals 3. So all c does overall is change the vertical position of the parabola. And again, we look at checkpoint number 2. Check it out. Number 2 asks us to compare these equations with f of x equals x squared. So for the first one, we look at the fact that this is a negative one, not a positive one. So we know that it's the same width, but that it opens down. And we know that because of this negative 4, that it's going to start going down 4. So our vertex is 0, negative 4. It's got the same axis of symmetry, the same horizontal line going through it. If we look at these, they have the same horizontal line going through it. This problem, 3x squared plus 9, the a is larger, so the parabola is going to be narrower. It's got the same axis of symmetry because it also opens up at 0. Its vertex is 9, and it opens upward because a is positive. And then with c, it's positive, so it opens upward. It has a smaller than 1a, so it's wider. It's got the same axis of symmetry, and c is 2, so its vertex is 0, 2. So I'm hoping that you're getting to a point where you can just look at an equation and know what the graph is going to look like. Example 3 is another one that they ask you to do a graphing calculator with, so we're actually skipping a lot around. What I do want you to notice, all of the problems that we've been working with, b equals 0. So it's not 2x squared plus 3x plus 5. There's no 3x in there. There's no just a number with an x. b always equals 0. Because the vertex is x, y, and you find x by saying negative b over 2a. When b equals 0, x always equals 0. So you end up with lines that are always along the x-axis. So all of the equations that we're working with today, the parabolas are going to be along that x-axis because there is no b. There's no left or right motion. When b is 0, the vertex is on the x-axis, and the vertex moves left or right based on b not equaling 0. When b doesn't equal 0, then there's left and right movement. Okay? The homework tonight, page 637, you're going to do numbers 10 through 22 even, and 29 to 32 all. I hope that this is just getting you better at recognizing the properties of parabolas and how these equations work. Let me know if you have any issues, and I will talk to you tomorrow. Thanks.